Hello YouTube, this is Mr. Bakari, and today we are going to convert complex numbers. That is, take complex numbers in rectangular form and convert them to polar form, or what we sometimes call trig form, and back from polar form to rectangular form. So we're going to cover it all in this video. Okay, we want to start with just the standard or rectangular form of a complex number. Now, you may have seen these previously when solving quadratic equations. When you use quadratic formula and you get a negative under the square root, then you get unreal solutions or imaginary or complex solutions. Okay. These numbers are made up of a real part, which is A, plus or minus an imaginary part, which is BI. Okay. So the most important thing that I think is we need to cover first is with my students, I always have them sketch a complex number to get an idea of where it is and how that kind of lends to how to convert it. So let's talk about the complex plane real quick. The complex plane is how we graph these, where we take the horizontal axis and it becomes the real axis. So that's where we graph A, our real number. And then the vertical axis becomes the imaginary axis, and that's where we would graph BI. Okay. So for example, we have a complex number here, -3 plus 5i. Okay. So that means the real number, -3, I will go 1, 2, 3 to the left, and then the imaginary number is positive 5i. So I'll go up 1, 2, 3, 4, 5, and that complex number is right here. Okay. So in the complex plane, r is the distance from the origin to the point a plus bi. Okay. That distance is sometimes referred to as absolute value. So visually, we can look at that as the distance from our complex number to the origin, and that is what we call r. Okay? And that's how you graph them. Now, the z equals, that just means complex number. That's what z stands for. So you'll see that a lot when working with complex numbers. Okay, so the first thing we need to do is look at how we get from this standard form to trig form. So as you can see over here on the left, I've got a complex plane and I've got a complex number written in rectangular form, a plus bi. Now, as you can see there, a is equal to r cosine theta. Okay, so just simple right triangle trig can show us that a is in fact equal to r cosine theta. And you can say the same of b. B is equal to r sine theta. Okay? So since they are equal to r cosine theta and r sine theta, we can replace them. Okay? So that's what you see right here. Now, both terms have an r. If we factor r out, then we have the trig form of our complex number. Okay? One little note, the I comes in front of sine. So we move the I from behind sine theta to in front of sine theta. Okay? And that allows us to write the shorthand of the trig form of a complex number, which is r cis theta, where C stands for cosine theta, I stands for I, and S stands for sine theta. Okay? So that's what we're trying to convert to first. So let's look at a couple examples. So on the left here, we've got z equals 5 minus 5i. And I'm just going to do a rough sketch on a complex plane and see where this lies. So my real part is 5. I'm going to go right 5. And then my imaginary part is negative 5i. So I'm going to go down. And so my number is somewhere about there. Now, let's look at, there's r, our distance to the origin, right? So as you can see, we went right 5 and down 5. Okay. And that forms a right triangle. So that we can find with that information, we can find R by using Pythagorean theorem. Okay. We can also see that our side lengths are the same, which means that our reference angle here is a 45-degree angle. Okay. So in order to write this in trig form, the reason why I drew this out is because all we need to do is find R and theta. Okay. So like I said before, R can be found using Pythagorean theorem here. So if we do that, we will get 5 root 2 for R. Okay. And then I can write CIS, which remember is short for cosine theta plus I sine theta. And then I need the angle. So the angle is right here in red, this red arc. So like I said before, this is a 45-degree angle because I can see this is a 45, 45, 90. So in radians, in terms of pi, this big angle here is 7 pi over 4. And now we have our trig form. Okay. Now this is the shorthand. Okay. I will write that expanded out. So that is R, which is 5 root 2 times cosine theta plus I sine theta. Okay. Now we want to replace theta with 7 pi over 4. So I'm just going to take that out and plug in 7 pi over 4. Okay. So these are equivalent. This is the shorthand. This is the expanded form. Okay. Let's try another one here. This one is 1 plus I root 3. Okay, so where does that lie? So we will go right 1 and up root 3. Okay. So again, if we extend here, and I just kind of draw a right triangle, I went right 1 and up root 3. And we can find our hypotenuse by using Pythagorean theorem, or as you can see here, this is a special right triangle. Our R is 2. Okay? So R is 2, followed by CIS, and now we have to find theta right here. Well, as you can see, this is a 30, 60, 90 triangle. So theta is 60 degrees, or in terms of radians, that's going to be pi over 3. Okay? So these are our conversions of a complex number from rectangular form to trig form. Okay? And again, this is the extended form of that. We can also extend this one. This would just be 2 times cosine pi over 3 plus I sine pi over 3. All right? And that's how you convert them. Now, let's go from trig form back to rectangular form. Now, this is quite easy. All we need to do is evaluate cosine at theta, evaluate sine at theta, and then distribute r. Okay? Very simple. So, if you want to draw out pi over 6, right? Okay, that's a 30 degree. And so this would be a 1, and this would be a root 3, and this would be a 2. So as you can see, cosine at pi over 6 is square root of 3 over 2. So I'm just going to replace that with square root of 3 over 2. And sine is y over r, which is 1/2. Now I will distribute root 2, which is my r value, and I get square root of 6 over 2 plus 1/2. And now I will move the I to the back because that is in the form a plus bi. And now this is the rectangular form of my complex number. Okay, let's go ahead and try this last one over here. Now I'm going to expand this just so we can see it like this. So I'm going to write 3 times cosine at 2 pi over 3 plus I sine 2 pi over 3. Okay, that's our expanded version. Now, 2 pi over 3 is over here, second quadrant. Okay, and this would be a 60 degree, our reference angle here. Okay, so this is root 3. This is -1, so we went left, and this would be 2. Okay, so I'm going to work this out. I'm going to evaluate cosine at 2 pi over 3. Cosine is -1/2 plus I, and then sine at 2 pi over 3 is y over r, which is root 3 over 2. Okay, and now I will distribute r, which is 3. So 3 times -1/2 is -3/2. And 3 times I root 3 over 2 is going to be positive 3 root 3 over 2. And then we will move the I behind b. So we have the form a plus bi. And this is our complex number in standard form. So that is how you convert complex numbers. I hope this helped you out, and I will see you in the next video.